Welcome friends, thanks for joining CloudSatellite Learning. Today we're going to review AWS Proton. AWS Proton is a delivery service for container application. In this demo, we also going to use CloudFormation, ECS, Fargate, code deploy, code build, and Nginx Docker container. We do have our source code reside in GitHub. AWS Proton is recently announced service. It is a free service, small instance for this demo. So here is a workflow of AWS Proton. AWS Proton is responsibility model. Platform team going to create environment template that defines shared resources and deploy environments. Platform teams also going to create service template that defines infrastructure monitoring and CI/CD resources. Developer login with their restricted access account and select service template created by platform team. They can link their source code package and deploy their application in target environment. So here is our application set in GitHub. We're going to use Nginx Docker image in the form of Docker file. We have two branches created for our demo. Let's get started. So before creating a service, let's take a look how the portal is defined. It's self-explanatory, where you can see like environment template and service template need to get created. There is a account role is also required. Once you deploy containers, then you have to deploy your service. Let's take a look how to create a template. So here, Amazon provide predefined sample templates for Fargate and Lambda functions that you can use for your deployment. Or you can create your custom templates and store those in S3. So in this demo, we're going to use Fargate environment template, which is predefined by Amazon. Give the name to your template. Add some description and additional details. We will skip encryption setting and tag for this demo. As our template is created, there is a settings comes to create a service templates. We will go and create service templates same way as we did with environment template. Amazon also provides service template by default. We will choose Fargate service. Name your service template and add additional descriptions. We will keep rest of the settings same as default. Here, you have to choose your service template created in previous step. All right, now it's time to create a service role. This role going to help us to create deployment resource. For example, code deploy, code build, and connect with our GitHub account. You can choose, if you have existing role, you can choose that as well. Our role is created. Now it's time to create environment. Let's take a look how the portal look like. In environment section, you can see right now we have not deployed any environment. We only have templates ready. That is service template and environment template. Let's deploy our environment. Create environment, choose our environment template. Select the account. You can use another account. Give the name to your environment. In this case, we are giving this production name. You can choose a service role. Here, we are not going to change Cedar blocks. We will use default. You can see it's 10 series block. Now you can see our environment template is in process. Let's create another environment for staging. Give the name as staging. Add some description. Select environment role and create. This time we're going to change seeder blocks. We will give different blocks for staging environment so that we can distinguish when we review VPC. Now both environment creation process is started. Let's take a look how it's working at the background. Let's have a look of the CloudFormation template. Here you can see like our production environment is created. Let's take a look what resources created by stack. You can see VPC is created, some of the public segments and routings, internet gateway, and most important is ECS cluster is created. But we haven't deployed anything in ECS cluster. It's just the cluster created, no resources. You can see that staging environment resources also created. You will follow the same pattern here because we are using same templates. In the ECS portal, we are using Fargate, not EC2, not external resources, but the services are 0 right now. Once we deploy our service template, we will see additional resources in ECS portal. Let's go back. Now it's time to create a GitHub connection. Go to the connection. It's by default, it's offered Bitbucket, GitHub, and GitHub Enterprise Server. If we have server hosted somewhere, you can connect that with this connection string. Right now, we're using GitHub account. Give the name to your connection. Now, next step is to install app. I already installed app. If you click on install app, it's gonna redirect to GitHub account, and after authentication, you will get that app created. Now our connection is ready. Let's go and create service. Select service template and give the name to your service. This is a staging service we're gonna create. Here you have to select staging branch, repository ID, and connection name. Here we are going to define which environment you want to deploy. So in this case, staging. I said desire instance 1 just to keep my cost low. Here is the name of Docker file that I want to deploy while building process. So the deployment specs you can download, and that basically controls your deployment process. Now our service creation is in process. Now let's go ahead and create similar service for production. Give the name to your service. Add some description. Select the branch as a main branch. Connection string. Here, again define your instances name and environment. This time we are going to select production environment. Desire instance 1, small, x small. Let's take a look how it looks in the portal. So service creation and deployment is in process. Let's take a look of CloudFormation templates, what's happening there. If you notice, our production service is failed. So here is a time to troubleshoot what happened exactly and where we can see failure messages. If we go to the events, and you can see like the target group's name while creating target groups resources is filled because of the longer characters. If we go back, Proton template cannot see exactly what happened behind the scene. Here it just show like deployment is failed and its rollback started. But we know what happened. So let's go and delete this resource so that we can recreate and address this issue. Select the resource and hit delete service. Provide service name. Now let's create similar service for production. So here is the name of your service, which is fine. Select the branch, repository details, and connection. The problem was occurred because of the instance name. Instance name was longer than expected. So this time we're going to put a short name, prod-inst. Select production environment. Select desired count and task size. Proceed further and create. Now go back to CloudFormation template. Let's see what's happening there. Here you can see so far so good, no issue, no error reported for recent deployment. So now let's take a look what resources created while creating services. This is for staging instance. So now we can see there are target groups created and additional services are created. If you notice, there are load balancer is also part of this deployment, and that's also been created. ECS security groups and public load balancer is attached with ECS. Similarly, in these stacks, there are more deployment stacks are created. If you see, the pipeline roles are there, code pipeline is also resources also created, and it's connected with the deployment. Similar things you can see with production deployment. Now let's go to the ECS service and see how we can see what we can see there. If it's here, you can see like staging deployment has one service and one task running under Fargate. Now it's deploying container. Let's go back to the EC2. Here we will check load balancer. We're expecting two load balancers, one for staging and one for production. Here you go. You can see two load balancers are created. If you go to the VPC sections, let's see how many virtual networks are created. If you remember, we use default seeder range for production deployment and customized seeder range for staging deployment. You can see those resources also created, and subnets are mapped accordingly. All right. Now check the code deploy. What is happening there? If you go to the code build or code pipeline or code deploy, you can see how many services are created. If you click on pipeline, there you can see like two services. This service is failed. Let's take a look why it's failed. In the build process, it's failed. If you want to go and see the error, so just click on this execution link details and you can see like trail all the logs. So here, as per the process, code build supposed to download container image. And here we already reached the pull rate limits from Docker. So that's why this build task is not able to download the required image. And that's basically the reason of failed. I have made some changes and now the deployment is working. I just changed the Nginx version from 1.20 and that basically proceeds. So here is the pipeline is for staging and one pipeline is for production. The pipeline deployment is complete. Let's take a look how it looks in the AWS Proton portal. Both our services instances are deployed. Let's take a look at the end URL of production application. If you run this application, we should expect our application running. Here you can see our application is running. This is a static page with one hyperlink at the bottom. And that hyperlink points to the CloudSatellite channel, YouTube channel. All these resources are created. If you click on these links, it's redirect to CloudSatellite channel. The application is working in ECS Fargate containers. Let's go back and check with staging environment. Similarly, grab the end URL, service end URL, and see how that application looks. If you notice, staging and production application looks same. So let's make a change in our source code and we'll see how that going to trigger and deploy our application once changes made in the source code repository. We are expecting here, once we change our staging or main branch, deployment should automatically trigger and push our changes into the Fargate containers. Let's take a look how our code deploy pipeline look like. If you go to the pipeline, its previous build was successful and it's just staying there. Go and change your source code. Select staging branch. Let's make a change of this AWS Proton bullet later. Update index.html file. As soon as we commit this change, we are expecting our deployment should trigger. If you refresh this page, you can see pipeline start triggering. Let's make the same change for production. This time, we're going to add production keyword so that we can distinguish once our both deployment is complete. Refresh the page. You can see it's automatically start triggering. If you go to the AWS Proton portal, you can also see the deployment is in process. Let's wait for completion. As you can see, both deployments are complete. Let's hit the service end URL. Here you can see staging tag is added for staging environment. Let's take a look at production application. Here you can also notice like production tag is also added for production application. Thanks for watching. Please subscribe and share.